So let's assume we have a linear function. Okay, we have y is equal to absolute value of 2x plus 3. Okay, what we do when we're trying to graph absolute value functions, we do exactly the same things as we did when we're solving absolute value equations. So what we're going to do is we're going to break this up to the positive and to the negative. Okay, so this becomes y is equal to the positive of this is whatever that is, right? Which is 2x plus 3. The negative of that becomes y is equal to negative 2x plus 3, which means y is equal to negative 2x minus 3. Okay. This is a linear function, it graphs a line. That is a linear function and it graphs a line. So let's draw our two equations, right? And I shouldn't really be representing this as y and that y. This is y, the positive version. This is y, the negative version. And the reason I'm going to name these like this, because on the graph, I want to, you know, distinguish between which graph, which line is which function. Okay, so let's create our graphs. Okay, let's graph this one first. The y-intercept is 3, the slope is 2. And we talked a little bit about this in series 1 when we're talking about the slope of a line and the distance of, you know, 2 points. And you know, we will get into this a lot more later on, right? But this is basically an equation of a line, which is y is equal to mx plus b. That's your y-intercept and that is your slope. So your y-intercept is 3, 1, 2, 3. Okay, and our slope is 2, which is 2 over 1. So we go up to 1, 2 over 1. Okay, and this is, or down 2 over 1, and this is our line. Okay, and this is the line for y positive, the positive branch of this. Let's graph this one. Negative 3, 1, 2, 3, right? That's our y-intercept, and our slope is negative 2. So we go down 2 over 1, or up 2 and over this one. Okay, and this guy is going to go there. It's going to look like that, and this is our y negative. Okay, so this is the graph of this line. This guy is the graph of that line. We haven't graphed this guy yet. This guy is here, but this isn't the graph of that, because this is not a function, right? To be a function, the definition of a function is for a given input, your input is your x value, you can only have one output, which is your y value, right? And for this, if you know, they call this the vertical line test. If you draw a vertical line, you're going to hit the, you know, the lines in 2 places, right? So over here, other than this point here, when x is negative 3, 1, 2, 3, y could be 2.5, it looks like, or negative 2.5. That's 2 different y values, so that's not a function. So we're going to have to see, you know, where our function lies. And the way it works is we're either going to kill the bottom part of this graph or we're going to kill the top part of this graph. Now, 2 ways you can look at this. The first way is y is equal to absolute value of this whole thing. So this whole thing is always going to be positive. That means y is always going to be positive. That means the top of the graph is the graph of that. Or you can test a point, and I like testing a point because sometimes I have brain farts and I do the wrong thing, right? I decide what the answer is and I do the opposite of it, right? And if you've seen some of my videos you'll know I make, you know, little silly mistakes here and there, which is part of the game, right? Yeah, I got to be focused on, you know, on what you're doing, not to do that, right? So I'm going to test the point, right? Or come up with things you can do to make it idiot proof so you don't make mistakes, right? And what I'm going to do is I'm going to test a point that is not this point here where the two lines cross. So I'm going to test anything which is not this. So what I'm going to test is x is equal to 0, because that's the easiest point to test, right? So I'm going to plug in x is equal to 0 here. So y is equal to absolute value of 2 times 0 plus 3. 2 times 0 is 0. So y is equal to absolute value of 3, which is just 3. So when x is 0, y is 3. So when x is 0, y is 3. So we know this point is on the graph. And since I told you this is a function, if that point is on the graph, then this bottom point is not. So what we end up doing is killing the bottom guys, right? So the graph of this function looks like this, right? That's what it looks like. It's a bounce off the x-axis, and that happens to be a function, right? And just one other thing, if you wanted to find out where these two lines cross, because they're not always going to be on the x-axis, we can move this thing around, and we will talk about this later. I just wanted to do this little intro to it. But all you got to do to find out where these two lines cross, you set y, positive y and negative y equal to each other. You say, let's do this here, right? So we say let y positive equal y negative. So you set this equal to this. So this becomes 2x plus 3 has to equal to negative 2x minus 3, right? And then solve for x. So grab negative 2x, bring it over, plus 2x. So this side becomes 4x is equal to 3 comes over, becomes negative 3 minus 3. So it becomes negative 6. Divide by 4, divide by 4. So x is equal to negative 3 over 2, which is negative 1.5, right? So that would be our x position. To find our y position, we set x is equal to 0 either here or here. Doesn't make a difference. Or here, really, right? Let's do it for this one. So y is equal to 2 times negative 3 over 2 plus 3. 2 kills 2. Negative 3 plus 3 is 0. So this point here is negative 3 over 2 and 0. Hopefully that's on the graph. I think it is. Okay. So this point here is negative 3 over 2 and 0. Okay. And this procedure, what we just did here, is exactly what you would do, irrelevant of how complicated a function we had that we had to graph. So what we're going to do in this video is graph the absolute value of a quadratic function, right? Because I love the way these things look, and I do want to go through it. And as I mentioned before, graphing quadratic functions requires a technique called completing a square, and in the future I will, you know, make a whole series on graphing polynomial functions and not polynomial functions, but I haven't got around to it yet, you know, laying out all the steps. So this may seem a little bit you know, rapid, quick going through this, and if you get lost in the process, you know, if you've never seen this before, don't worry, I will cover this. And if you have seen this before, hopefully this is a good review. And if you're just interested in seeing how this looks, hopefully you'll find this process interesting, because it's a sweet process. It's very meditative, sitting there and just going, just doing the whole thing. And it's sort of the same rhythm as what we did for a linear function, which is basically breaking the absolute value function or equation into two pieces, taking the negative and the positive version of it. Okay, so let's assume we have the following absolute value quadratic function. Okay, let's make sure we can fit all of this here, because it's going to take a little bit of space to do this, right? And hopefully we can do it all in one sheet without skipping too many steps, right? So we're here. Let's put this guy here. So let's assume we have the following function. Y is equal to, now I'm going to leave the coefficient in front of the x squared as 1, so we don't, we're skipping over one step where we have to take the coefficient out of the brackets when we put the brackets around the x squared and the x term in the last video, right? So we're going to have this minus, let's say this is, let's make it simple, 8x plus 2. Okay, now that's a quadratic function, right? Now what I'm going to do is I'm going to put this thing, put absolute values on this, introduce absolute values. And I'm not going to put the whole thing in the absolute value. I'm going to put my absolute value here, these two guys, right? And as we talked about before, the absolute values basically mean the inside of this could be positive or negative, and as soon as we use the absolute value power, whatever is inside becomes positive, irrelevant of it being positive or negative, right? Now to be able to graph this, what we need to do is take a look at what this looks like both in the positive and the negative. So I'm going to split this up into two different streams. Okay, I'm going to take the positive on the inside and the negative of the inside. Okay, so let's take the positive one first. Y is equal to, the positive of the inside is just whatever's on the inside, x squared minus 8x plus 2. The negative branch of this is negative this whole thing. So the way we write it is we go y is equal to, we put it in brackets, x squared minus 8x plus 2. Okay, so I basically converted the absolute value symbols here to brackets and I put a negative in front. And what I'm going to do now is apply the negative inside the bracket. So this guy becomes negative x squared plus 8x plus 2. Okay, easy. What we're going to do now is we're going to have to complete the square for this and complete the square for this. Let's do this one first. What we do is we put this in brackets. The coefficient in front of the x squared is already 1, right? The x squared is solo, so we don't have to take anything out of the bracket. So what we do is we grab negative 8, divided by 2, we get negative 4. We're going to circle this, we're going to square it, we're going to get 16. And we're going to circle that, because we're going to use both those terms, right? Now what we're going to do is we're going to add and subtract 16 inside the brackets. So what we have here now is bracket x squared minus 8x plus 16 minus 16 plus 2. Hopefully I got enough room to do the negative one there, right? Now what we have is this guy is a perfect square, right? Two numbers that multiply to give us 16 and to give us negative 8 are negative 4 times negative 4 gives us 16. Negative 4 plus negative 4 gives us 8. So that is the factor of that guy. And I'm going to take the negative 16 out of the bracket. There's nothing inside the bracket, outside the bracket to multiply that, so it's just negative 16 that comes out, right? So negative 16 comes out of the bracket. This becomes a perfect square, which becomes x minus 4 squared. Negative 16 comes and adds to 2, becomes negative 14. Okay, This is y on the positive branch. I should have put a plus here to indicate that this was the y on the positive branch, right? And this is y on the negative branch that we took away. Okay. Now what we're going to do is do this side. And this is of the form that we talked about, right? Where y is equal to a bracket x minus p squared, all squared plus q, right? So we can graph this guy. We're going to do the same thing here. We're going to put this guy in brackets, the x squared and the x term in brackets. We need to grab the negative out of the bracket. So negative 1 comes out. And now we got x squared, and we're going to have to compensate for the 8 term, right? So we're going to divide 8 by negative 1, which makes it negative 8. So this becomes negative 8x plus 2. Now what we're going to do is take negative 8 and divide it by 2, right? So what we're going to do is take negative 8, right, divide it by 2, which gives us negative 4. We're going to circle it, we're going to square it. This becomes 16, and we're going to circle that. Okay. And we're going to do the same thing to this. Use the 16, add and subtract that inside the brackets the same way we add and subtract 16 inside the brackets here, right? So this thing becomes, the y negative becomes negative bracket, negative 1, and I'm not going to put the 1 there, we just know it's negative, right? X squared minus 8x plus 16 minus 16, close your bracket, and we've got plus 2. I'm putting the plus 2 one level down, right? I don't have enough room to work with. This is now a perfect square. Its factor is negative 4. I'm going to grab the negative 16, right? I'm going to grab negative 16, bring it out of the bracket, but keep in mind there's a negative number here, so that multiplies the negative 16, and it becomes positive 16. And then we're going to add that to 2. So what we've got right now is the y of the negative branch becomes negative x minus 4 square, bracket, squared plus 18. Okay. So what we have right now is 2 parabolas that we need to graph. Okay. We're going to graph this guy, and we're going to graph this guy. And this is going to be a small graph, but we're going to put it here. Okay. And what you're going to see is they're going to be lining up on their x's, on their axis of symmetries, and their y's are going to be shifted. Okay. So let's do this so we don't, get too confused. Let's put our axes down as with the blue pen. Okay. So we're going to go here. Sure, let's do it from here. Go down. Let's see how far down we can go. Oh, way off board. So I can go to about there. So I'm going to put this guy here. Okay. That's our x, and that's our y, right? Let's put the y here. Now, this is not going to be to scale, the drawing that we're going to do. We're just going to do a sort of a visualization of it, right? And at some point I'm going to go back to this and do this really in depth, right? So what we got here is this. Let's graph the positive one first. The positive one says this: our vertex is going to be 4 and negative 14. So let's assume this is x is equal to 4 and y is equal to negative 14. Let's put it down here. Okay, so this is, can you even see this point? Nope. Let's put this guy here. This is 4 and negative 14. That's our vertex. This is positive in front of the bracket here, so we know the parabola opens up. We're going to go back to here and find our y-intercept. by setting x is equal to 0, right? We set x is equal to 0, and we get y-intercept of 2. So y-intercept is 2. Let's assume 2 is here, right? Our axis of symmetry is this guy here. Is the line x is equal to 4? Okay. That means whatever distance we're away from the axis of symmetry on this side, whatever the graph looks like here, it has to be symmetrical about this line. So this distance here, this guy is 4 units away from the axis of symmetry, right? Because the vertex is x equals 4. So all we do is we go 4 units away here. And our point here is going to be 0 and 2. And our point here is going to be 8 and 2. 2. Oh my god, I put this at negative 2. I gotta move it up. This is going to be 2 here, right? My bad. These little brain farts are no good, right? So this point here is 0 and 2, and this point here is 8 and 2, not these guys, right? Oops. So what we got here is the graph goes from here all the way up. So this guy goes like this and like this. Okay, sorry about that mistake. Hopefully that didn't throw you off, and if you were paying attention, hopefully you caught the mistake and you were wondering what was going on, right? But that's what the graph of the positive this looks like, and I'm going to put y positive here. Okay, now what we're going to do is graph the negative one. The negative one, the vertex is 4 and positive 18. So the 4 we already got here. The positive 18, I'm just going to assume it's here. So this point here is 4 and 18. Okay. The y-intercept, we're going to set x is equal to 0, but we're not going to do it here. We're going to do it in the top one here. If we set x is equal to 0, this becomes 0, that becomes 0. So it's 2 again, right? So it's exactly in the same location here and here. So, and we know this is negative, right? The parabola is, the coefficient in front here is negative. So we know the parabola opens down. So this guy looks like this. Hopefully we can do this nice and neat. And this is the negative one, right? So the negative parabola opens down, the positive parabola opens up. Now what we need to do is either eliminate the bottom part of this where they cross, or the top of part of this where they cross. And we're not going to eliminate it from the x-axis. We're going to eliminate it from where they cross, where they're intersecting, right? And that, whatever the result is going to be the graph of this top guy, because this isn't, you know, what we've drawn right now is two functions, is this guy and this guy, right? So that's two functions. And if we do a, you know, definition of function is for a given input you can only have one output, right? For a given x value you can only have one y, right? And this thing right now, if we looked at this as one graph, it wouldn't be a function, because for a specific x value, let's say x is equal to 4, we could have 18 or negative 14. It doesn't work. We've got two different outputs, right? So we still haven't graphed this guy yet, right? We haven't graphed the original function we started off with. So what we need to do is test a point, test an x value in the original function to see if it's gonna give us, you know, put us on the top part of this or put us on the bottom part of this. And you know, if you've done these things, You know it's going to put us in the top part of this, but let's do the test anyway, okay? Because I like doing the test. And one of the reasons I like doing the test is because sometimes I have, you know, I do little mistakes just the way I did here, right? Instead of putting the y-intercept at +2, I put it at -2. So that was a serious brain fart, serious mistake. So I want to make sure I don't make a mistake. So I do a test point. Now I'm not going to test where these two things cross. I'm going to test an x value where they don't cross, because if I test, you know, x is equal to 8 or x is equal to 0, then it's going to put me either here or here. So I won't know if it's the top part or the bottom part. So what I'm going to do, I'm going to test x is equal to 4 in the original equation, right? And it has to be in the original equation. And once I do that, I'm either going to end up here or I'm going to end up at the bottom part here. Where am I? Bottom part there, right? So we're going to take the original function and we're going to put x is equal to 4 and see what we end up getting, right? Where should we do this test? Let's do it here. So we're going to substitute x is equal to 4 for x in the original function, right? Let's do this in red so we don't get too confused with the actually let's do this in blue with all the green that we have here, okay? So we're gonna go substitute 4 for x here, right? So we're gonna have y is equal to absolute value of 4 squared minus 8 times 4, oops, plus 2. 4 squared is 16, right? So this is going to be absolute value of 16 minus 4 times 8. 8 times 4 is 32 minus 32 plus 2. And this is going to be 16 minus 32 is negative 16, right? So we got negative 16 plus 2. Absolute value of negative 16 is 16, right? Because it's positive, right? As soon as we use this power, makes that number positive. So 16 plus 2 is 18, right? So what this tells us is when x is equal to 4, y is equal to 18, and that puts us up here, right? That puts us up here. So what that means is this point is on this function, so this point is not. So what we end up doing is we end up killing everything below the intersection line here. So all of these are dead. Okay. So the graph of this function is this. Bounces from at 8 and 8 and 2 at this point, bounces up, goes up, comes down, bounces at 0 and 2 and goes back up again. So let's draw this in blue, maybe blue, black. Let's do this in black. Maybe that'll show up better. So our graph looks like this. Okay, neat little graph. The graph of an absolute value quadratic function is this. Right. I hope you liked. I hope this isn't too messy. On my little screen it looks chaotic, but there is a rhyme and reason behind it. Okay, I hope you liked. They're fun to do these things, and we will definitely delve into this a lot more in the future. Okay, that's it for now. I'll see you guys in the next video.